Underground nuclear testing is the test detonation of nuclear weapons that is performed underground. When the device being tested is buried at sufficient depth, the explosion may be contained, with no release of radioactive materials to the atmosphere. The extreme heat and pressure of an underground nuclear explosion causes changes in the surrounding rock. The rock closest to the location of the test is vaporized, forming a cavity. Farther away, there are zones of crushed, cracked, and irreversibly strained rock. Following the explosion, the rock above the cavity may collapse, forming a rubble chimney. If this chimney reaches the surface, a bowl-shaped subsidence crater may form. The first underground test took place in 1951. Further tests provided information that eventually led to the signing of the Limited Test Ban Treaty in 1963, which banned all nuclear tests except for those performed underground. For then until the signing of the Comprehensive Test Ban Treaty in 1996, most nuclear tests were performed underground, in order to prevent nuclear fallout from entering into the atmosphere. Background: although public concern about fallout from nuclear testing grew in the early 1950s, fallout was discovered after the Trinity test in 1945. Photographic film manufacturers would later report as fogged films. This was traced to packaging materials sourced from Indiana crops, contaminated by the Trinity, and later tests at the Nevada test site, over 1,000 miles away. Intense fallout from the 1953 Simon test was documented as far as Albany, New York. The fallout from the March 1954 Bravo test in the Pacific would have scientific, political and social implications that have continued for more than 40 years. The multi-megaton test caused fallout to occur on the islands of the Rongerik and Rongelap atolls, and a Japanese fishing boat known as the Daigo Fugayu Maru. Prior to this test, there was insufficient appreciation of the dangers of fallout. The test became an international incident. In a PBS interview, the historian Martha Smith argued, in Japan, it becomes a huge issue in terms of not just the government and its protest against the United States, but all different groups and all different peoples in Japan start to protest. It becomes a big issue in the media. There are all kinds of letters and protests that come from, not surprisingly, Japanese fishermen, the fishermen's wives. There are student groups, all different types of people, that protest against the Americans' use of the Pacific for nuclear testing. They're very concerned about, first of all, why the United States even has the right to be carrying out those kinds of tests in the Pacific. They're also concerned about the health and environmental impact. The Prime Minister of India voiced the heightened international concern when he called for the elimination of all nuclear testing worldwide. Knowledge about fallout and its effects grew, and with a concern about the global environment and long-term genetic damage. Talks between the United States, the United Kingdom, Canada, France, and the Soviet Union began in May 1955 on the subject of an international agreement to end nuclear tests. On August 5, 1963, representatives of the United States, the Soviet Union, and the United Kingdom signed the Limited Test Ban Treaty, forbidding testing of nuclear weapons in the atmosphere, in space, and underwater. Agreement was facilitated by the decision to allow underground testing, eliminating the need for on-site inspections that concerned the Soviets. Underground testing was allowed, provided that it does not cause radioactive debris to be present outside the territorial limits of the state under whose jurisdiction or control such explosion is conducted. Early history of underground testing. Following analysis of underwater detonations that were part of Operation Crossroads in 1946, inquiries were made regarding the possible military value of an underground explosion. The Joint Chiefs of Staff thus obtained the agreement of the Atomic Energy Commission to perform experiments on both surface and subsurface detonations. The island of Amchitka was initially selected for these tests in 1950, but the site was later deemed unsuitable and the tests were moved to the Nevada test site. The first underground nuclear test was conducted on the 29th of November 1951. This was the 1.2 kiloton Buster Jangle Uncle, which detonated 5.2 meters beneath ground level. The test was designed as a scaled-down investigation of the effects of a 23 kiloton ground-penetrating gun-type device that was then being considered for use as a cratering and bunker-buster weapon. The explosion resulted in a cloud that rose to 3,500 meters and deposited fallout to the north and north-northeast. The resulting crater was 79 meters wide and 16 meters deep. The next underground test was Teapot S on the 23rd of March 1955. The 1 kiloton explosion was an operational test of an atomic demolition munition. It was detonated 20.4 meters underground, in a shaft lined with corrugated steel, which was then backfilled with sandbags and dirt. Because the ADM was buried underground, the explosion blew tons of earth upwards, creating a crater 91 meters wide and 39 meters deep. The resulting mushroom cloud rose to a height of 3,657.6 meters and subsequent radioactive fallout drifted in an easterly direction, traveling as far as 225 kilometers from ground zero. On the 26th of July 1957, Plumbob Pascale was detonated at the bottom of a 148 meters shaft. According to one description, it ushered in the era of underground testing with a magnificent pyrotechnic Roman candle. As compared with an above-ground test, the radioactive debris released to the atmosphere was reduced by a factor of 10. Theoretical work began on possible containment schemes. Plumbob Rainier was detonated at 899 feet underground on the 19th of September 1957. The 1.7 knots explosion was the first to be entirely contained underground, producing no fallout. The test took place in a 1,600 to 2,000 feet horizontal tunnel in the shape of a hook. The hook was designed so explosive force will seal off the non-curved portion of tunnel nearest the detonation before gases and fission fragments can be vented around the curve of the tunnel's hook. This test would become the prototype for larger, more powerful tests. Rainier was announced in advance, so that seismic stations could attempt to record a signal. Analysis of samples collected after the test enabled scientists to develop an understanding of underground explosions that persists essentially unaltered today. The information would later provide a basis for subsequent decisions to agree to the Limited Test Ban Treaty. Canakin, the last test at the Amchitka facility, was detonated on 6 November 1971. At approximately 5 megatons, it was the largest underground test in U.S. history. International treaties, signed in Moscow on August 5, 1963 by representatives of the United States, the Soviet Union, and the United Kingdom. The Limited Test Ban Treaty agreed to ban nuclear testing in the atmosphere, in space, and underwater. Due to the Soviet government's concern about the need for the on-site inspections, underground tests were excluded from the ban. 108 countries would eventually sign the treaty, with the significant exception of China. In 1974, the United States and the Soviet Union signed the Threshold Test Ban Treaty. which banned underground tests with yields greater than 150 kilotons. By the 1990s, technologies to monitor and detect underground tests had matured to the point that tests of 1 kiloton or over could be detected with high probability, and in 1996 negotiations began under the auspices of the United Nations to develop a comprehensive test ban. The resulting Comprehensive Nuclear Test Ban Treaty was signed in 1996 by the United States, Russia, United Kingdom, France, and China. However, following the United States Senate decision not to ratify the treaty in 1999, it is still yet to be ratified by 8 of the required 44 Annex II states and so has not entered into force as United Nations law. Monitoring. In the late 1940s, the United States began to develop the capability to detect atmospheric testing using air sampling. This system was able to detect the first Soviet test in 1949. Over the next decade, this system was improved, and a network of seismic monitoring stations was established to detect underground tests. Development of the Threshold Test Ban Treaty in the mid-1970s led to an improved understanding of the relationship between test yield and resulting seismic magnitude. When negotiations began in the mid-1990s to develop a comprehensive test ban, the international community was reluctant to rely upon the detection capabilities of individual nuclear weapon states, and instead wanted an international detection system. The resulting international monitoring system consists of a network of a total of 321 monitoring stations and 16 radionuclide laboratories. 50 primary seismic stations send data continuously to the International Data Center, along with 120 auxiliary stations which send data on request. The resulting data is used to locate the epicenter and distinguish between the seismic signatures of an underground nuclear explosion and an earthquake. Additionally, 80 radionuclide stations detect radioactive particles vented by underground explosions. Certain radionuclides constitute clear evidence of nuclear tests. The presence of noble gases can indicate whether an underground explosion has taken place. Finally, 11 hydroacoustic stations and 60 infrasound stations monitor underwater and atmospheric tests. Books. The Containment of Underground Nuclear Explosions. Project Director Gregory E. Van der Vink, U.S. Congress, Office of Technology Assessment, OTA ISC 414. IAEA review of the 1968 book, The Constructive Uses of Nuclear Explosions by Edward Teller.